Okay, so I want to jump back into some more topics. So when we jump back into some more topics, I thought it'd be interesting to go ahead and look at um, fill rate. So fill rate is the magnitude rather than the probability of the stock out, and it's increasing. With this, we increase the replenishment order quantity. Increasing the replenishment order quantity decreases the relative magnitude of a potential stock out. So the formula for that is going to be the stock out magnitude is going to equal 1 minus f, which is the function of a normal loss curve, which provides the area of the right tail of the normal distribution, multiplied by the combined standard deviation for that replenishment cycle uncertainty, divided by the replenishment order quantity. So this is in the text, but that's kind of how you're going to understand that magnitude fill rate. Uh, so when we look at increased order size, increased order size can be used to compensate for decreasing the safety stock. So, if we order, say, 300, and our safety stock is 5, we have an average inventory of 155. When we order 200 and we have a safety stock of 8, we have an average inventory of 108. So you can see that we're able to decrease our average inventory, but we do increase our safety stock. It's an interesting phenomenon, but really it comes down to the way every business management manages it. So we have dependent demand replenishment, and this is inventory requirements are a function of known events that are not generally random. The dependent demand does not require forecasting because there is no uncertainty. No specific safety stock is needed to support time-based procurement programs such as an NRP, and no safety stock assumes procurement replenishment is predictable and constant, and vendors and suppliers maintain adequate inventories of safety stock. So whenever you have a safety stock requirement on your vendor suppliers, it's always beneficial to you. You put the safety time into the requirements plan. So, when we approach safety stock, we can put safety time in the requirement plan. And, example, this is the order of component earlier than needed to assure that the timely arrival. We can over plan our top level demand. And this is a procedure to increase the requisition by a quantity specified by some estimate of unexpected error. So we can assume that there's going to be an error, but also assume that it's not going to exceed a certain percent. And then we can utilize standard techniques to set safety stocks directly for a component rather than, just kind of go across the top level in our demand. And when we look at how do we approach implementing inventory management policies, we can be reactive or pull and have that approach. And that responds directly to the customer demand to pull the product through the distribution channel. We can look at a planning approach where we proactively allocate inventory on a basis of forecasted demand and product availability. And we can also look at a hybrid approach that uses a combination of push and pull. So inventory control uses reactive approaches, and inventory control defines how often inventory levels are reviewed to determine when and how much you order. So we have a perpetual review where we're constantly reviewing, constantly monitoring inventory levels to determine inventory replenishment needs, or we can do a periodic review. Maybe we look at them weekly, maybe we look at them monthly, maybe quarterly. That seems like it's too far. So when you look at a perpetual review formula, your reorder point in units is always going to equal your daily demand in units multiplied by your average performance cycle life in days, and then add it to your safety stock. Whereas a periodic review is a little more complicated. You're going to look at your reorder point is your average daily demand, and then it's going to be multiplied by your average performance cycle plus your review period in days divided by 2, and then you take that multiplied by your daily demand, and then you add that to your safety stock. So assumptions of classical reactive inventory logic, all customers in all market areas and all products contribute equally to profits. That's not true. Infinite capacity exists at the production facility. That's not true. Infinite inventory available at the supply location. That is not true. Performance cycle time can be predicted that a cycle lengths are independent. Customer demand patterns are relatively stable and consistent. That's not really true either. Each distribution warehouse timing and quantity of replenishment orders are determined independently of all sites, including the supply source, and the performance cycle length cannot be correlated with demand. So if we look at planning approaches to coordinate requirements across multiple locations of the supply chain, there are two main planning approaches. There's a fair share allocation where we provide each facility with an equitable distribution, limit ability to manage the multi-stage inventories as a fallback of this. And then there's requirements planning. We integrate across the supply chain. We take into consideration these unique requirements and we distribute, we allocate where it's going to be used and generate revenue. And we allocate it where it's going to best optimize the company. And this is where utilizing your materials requirement planning, your MRP system or distribution requirements planning, a DRP system is really going to help you have the data to do that. So, in a fair share allocation, you're just going to say, I've got 3 warehouses, I've got 600 units. Whereas if we look at and we're going to say, we're going to give it to where it's going to make the most difference, where it's going to help us make the most profit. So, and you can get into different spreadsheets, different formulas, and once again, this is just something that every business is going to do differently. And I think that's the biggest takeaway that I would give you for inventory is inventory is always done differently. So you need to know your company's policy. You need to know your business, your suppliers, so you can contribute to it. That's planning scheduling systems can really help. You got to look at the different echelons of your supply chain. And that there are limitations to all planning approaches. So you really have to understand all of that. You have to understand to be collaborative. You have to look at your replenishment programs. How quickly can you respond? Can you implement tools like vendor managed inventory or replenishment systems? And I would just leave you with that inventory is a dynamic topic that no company does the same, and every company does it the best way that fits to them. So learn your system and try to contribute when you get to your first organization. So with that, I'll leave you on this topic. Please let me know if you have any questions.